The first method of factoring we're going to learn is how to factor out a greatest common factor, or a GCF. This is the most important type of factoring because it's what we're going to do in every single problem as the first step. We always want to look for a GCF first. Then we're going to find the GCF, write it on the side of the box, and fill in the top by asking the question, what do I multiply to my GCF to get blank? And that blank is just filled in with whatever is on the inside of the box. And our last step is to rewrite our answer as multiplication. So looking at our first example, I notice when I look at this problem that there's an x in both my terms. Alternatively, you could notice something like they're divisible by 3 or divisible by 9. As soon as you see that the terms are all divisible by the same thing, then you're going to put it in what I call the skinny box or a skinny rectangle. Now we're going to put our GCF on the side. So what is the GCF, or the greatest common factor, of 9x squared and negative 27x? A GCF means the biggest number that goes into both terms, which is going to be 9. And then with variables, we take out the lowest exponent, so I can take out an x. To fill in the top, I think, what do I multiply to 9x to get 9x squared? Well, all I need is to multiply by an x. Going to the next box, I say what times 9x is negative 27x? Negative 3. And then my final answer is to write the side, 9x, times the top, x minus 3. And if I wanted, I could distribute that out to make sure that I got it correct. So looking at the next one, when I first glanced at this, I noticed that all my terms have an x. I also noticed that they're all divisible by 10. You don't even have to start with noticing the GCF. As long as you see there's a common factor, go ahead and stick it in the skinny box. So for this one, let's ask what is the biggest number that goes into 10, 40, and negative 30? That's going to be 10. And I do have an x, and that's the highest exponent I can take out. So to fill in the top, I say what times 10x is 10x cubed? That would be 1x squared. What times 10x is negative 40x squared? So I need a negative 4 and an x. What times 10x is negative 30x? Negative 3. And my last step is to write that as multiplication. Side, 10x, times the top, x squared, minus 4x, minus 3. Last one, I have this like huge humongous thing. I notice I have a lot of variables going on, and I notice that all my numbers are divisible by 4. So I'm going to start this problem with the skinny box. So 4, 12, and 16, the GCF is 4. Then I look at my variables. Do each of my boxes have an x? Yes. What's the lowest exponent? X to the first. Then I look at my y's to see if they all have a y. Y squared, y squared. So I can take out a y. My GCF in this one is 4xy. When you start getting more complicated, it can help to take things one at a time. So I'm going to go through and do my numbers first. So just my coefficients. What times 4 is 4? 1. What times 4 is negative 12? Negative 3. What times 4 is 16? 4. Now I'm going to go and do my variables. So I have x and x squared. What times x is x squared? That would be x. What times x is x squared? Another x. What times x is x? I already have what I need. Move on with your life. Then I have what times y is y squared? That would be y. What times y is y? I don't need anything. What times y is y squared? Y. So once I write that all out, it's going to be my GCF 4xy times my top, which is 1xy, minus 3x, plus 4y. So one thing you should notice is that if I start with 3 terms, I should be ending my problem with 3 terms as well. So that is factoring we're rewriting as multiplication. Sometimes, though, they want us to solve. I know that they want me to solve if it obviously says solve, or if I see an equal sign. And when we see an equal sign and an x squared, this is going to change the way we do problems from how we've been doing them before. So when we have x squared and we want to solve by factoring, our first step is to get everything equal to 0. So in my first problem, I already have it equal to 0. So I move on and treat it like we did on the last screen. So I have 16x squared minus 24x equals 0. And I'm going to put the skinny box just around the terms on the left side. What would be my GCF? What's the biggest thing that goes into 16 and 24? 8. I have x squared and x, and I can take out an x. Then I say, what do I multiply to 8x to get 16x squared? That would be 2x. What do I multiply to 8x to get negative 24x? Would be negative 3. Write it as a product. So 8x times 2x minus 3 equals 0. And now we're going to use the zero product property from the last video, where we're going to split it, set it equal to 0, and solve. Because I know if two things multiply to 0, that means one of them has to be 0. So 8x equals 0, and 2x minus 3 equals 0. So the left side to solve, I'm going to divide by 8, so I get x equals 0. And here I'm going to add 3 and divide by 2. So x equals 3/2. So these, I have two solutions, and this is coming from the fact that I have a x squared instead of just a normal x. Now, what did I say the first step is if we're solving by factoring? If we're solving by factoring, it has to be equal to 0. So looking at this, I'm not equal to 0. How could I get it equal to 0 if it's currently equal to 15x? We're going to subtract 15x from both sides. But those aren't like terms. I can't combine squareds and x's. So this is going to give me 10x squared minus 15x equals 0. Now I have two terms, and I notice that they're both divisible by 5. They both also have an x, so I'm going to draw my skinny box. What's the biggest thing that goes into 10 and 15? 5. What about x squared and x? We can take out an x. Now we fill in the top. What do I multiply to 5x to get 10x squared? 2x. What do I multiply to 5x to get negative 15x? Negative 3. Now we write it side times top. And now we're going to split, set equal to 0, and solve. So 5x equals 0, and 2x minus 3 equals 0. So divide by 5, which means x equals 0. Add 3, and divide by 2. So x equals 3 over 2. Now, we happen to get exactly the same two answers there. Isn't that fun? Totally unintentional. Those are not always the same two answers. The last thing we need to look at is when I have basically the inside guts of when we used to multiply using the area model. So what I need to do now is get the outside. What we want to do is just focus on this top part for right now. I just want you looking at this top row. Totally ignore the 6x plus 4. And we're going to do the same process we've done in this video with just the top. So what can go into 3 and 2? Just 1. But they both have an x squared, so I can take out an x. So I'm going to take that out and put it on the side. And I say, what do I multiply to x to get 3x squared? I would multiply by 3x. What do I multiply by x to get 2x? 2. Now I'm going to look at the bottom and pay attention to the top. Okay, what do I need to multiply to 3x to get 6x? 2. And then we want to check 2 times 2 does give me 4. And to factor, my answer is going to be written as multiplication. So that's going to be the side, which is x plus 2, times the top, which is 3x plus 2. And you can always take a quick second to double check with multiplication that that works.